All right, welcome back to final review part 4. This will be the shortest of your videos because there's only 2 sections to be covered, but I do want to give you my final thoughts to wrap up this semester, as this is my last video for you guys. Some quick reminders. I am doing drop-in Zoom tutoring through ODI this Sunday from 1 to 3 p.m. So if you have any questions, feel free to pop on, ask away. I will be there. That can be anything from this material, the material you just learned, or any other review material. I hope you had a great semester. I had a great semester working with you guys. You were such a great group. You always showed up and had a lot to say and were really helpful for your peers. Stay strong during this challenging time. And, I never could have imagined that I would be finishing up this semester teaching you in my bedroom at home in the house I grew up in, and not in Columbus, but, we're all strong and resilient, and let's hope that we can all reconvene next year on campus. So, listen to these videos, do the practice problems. You will be prepared. It is still open book like the midterm 3, so just be practiced and be ready. And reach out with questions, and better yet, drop in during tutoring. All right. So 3.5 is similar to the sections I posted yesterday. They're pretty repetitive in that you do the same thing every time. So I'm only going to do one from 3.5, and then I'll do 2 from 3.6 for you guys. But let's get started. As we've always calculated our y-intercepts this semester, you're setting x equal to 0. So 0 squared over 0 squared minus 0 minus 6 is 0 over negative 6. So x is equal to 0. I'm wrong. Y is equal to 0. Sorry about that. So y is equal to 0. So 0, 0 is your y-intercept. Now to calculate our x-intercepts, we're really going to be focusing on the top in questions like this. So let's set x squared equal to 0, and we get x is equal to 0. So 0, 0 is also an x-intercept. I promise I made this question up and I did not plan for it to go perfectly for you guys. And for our vertical asymptotes, you're really going to be looking at the bottom. So here we have to factor x squared minus x minus 6. So we get x minus 3 and x plus 2. So our vertical asymptotes are at x equals 3 and x minus 2. And then for our horizontal asymptote, you're looking at the power of the top and the bottom. Here we see that they are the same. So then our asymptote, when they're the same, equals whatever their coefficient is. So here we can assume it's 1. So our horizontal asymptote is at y equals 1. Now when the top is bigger than bottom, then equals no asymptote. But when bottom is bigger than the top, there is an asymptote at 0. So key information there. I know it takes kind of a bit because it doesn't exactly make sense, and you kind of have to remember it. So kind of focus in on that. So now we're going to graph that information. And my biggest key to you here is when you graph this in a calculator, the asymptotes aren't going to show up. It's just going to look like it's approaching a certain value. So you still need to plot the asymptotes on here and then plot what the calculator gives you. So my vertical asymptotes I'm going to do first at x equals 3. And I recommend that you label everything. So I would just label that x equals 3 and negative 2. X equals negative 2. Now I don't know how your online formatting goes, obviously, because I have not experienced that for this class, but I just make sure you are careful with your graphing if they do make you graph. Now let's do our horizontal asymptote at 1. Okay. They're not obviously expecting perfection, but if it asks for labels, you really want to make sure you label. And now I know I have an x-intercept here. So from here, you could plug stuff in the calculator, or I'm going to plug in a value such as x equals negative 3. When I plug in negative 3 squared over negative 3 squared minus a negative 3 minus 6, I get 9 is equal to 9 plus 3 minus 6. So I get 9 over 6. So I know I'm going to get a positive value here. So it's probably going to go something like this because it's positive and it's going to have to approach the asymptotes. And now I'm going to plug in negative 1 to see what's happening on this side of the graph. And I'm going to say negative 1 squared over negative 1 squared minus negative 1 minus 6. I'm going to get 1 over 1 plus 1 minus 6. And I get 1 over negative 4. So it's going to be going down on this side. And what happens when I plug in just plain 1? I get 1 over 1 minus 6. So I get this. So it's also going down on this side. And then I can plug in something like 4 to see what's happening on this side. So when I plug in 4, square it, 4 squared minus 4 minus 6 equals 16 over 16 minus 4 minus 6. So I'm left with 16 over 6, which is positive. So I'm going to look something like this here. And I did that without a calculator. So you can too. If you don't have a graphing calculator, that's how you would go about it.